Hello, today we're going to build a bond optimization spreadsheet using Lindo's What's Best Linear Optimizer. Their website is www.lindo.com. That's Lindo.com. We're going to focus in on two things. Number one, since Excel's minimum function is not linear, What's Best might return suboptimal or bad solutions or mistakes when using it in the spreadsheet. So we're going to build our own imitation artificial minimum in What's Best that uses a What's Best adjustable cell as the min to trick it. For example, in our case, we want the minimum debt service. So if M of I is equal to min debt service in year I, then we want two constraints. One, Mi is less than or equal to M of I minus 1, or in other words, current min is less than or equal to the prior min. And two, Mi is less than or equal to ds of I, or in other words, the current min is less than or equal to the current debt service. However, we can employ this same trick for things other than debt service, like principal. Point 2 is very, very important. We're going to highlight the use of Excel's SUMIF function, which What's Best does understand and sees as linear, to build debt service tables from a list of bonds that's out of chronological order. As long as the format of the formula looks like SUMIF parentheses, column of cells with fixed values that won't vary, like dates, a pointer index selecting from the fixed values column, comma, a column of adjustable cells that What's Best will change, parentheses, What's Best will see a linear function of adjustable cells. In any specific cell, What's Best converts the fixed column into fixed unchangeable constants, zeros and ones, depending on whether they're equal to the pointer or not, which in turn multiply the values in the adjustable column. For example, if the date column has dates 1/1/2021, 1/1/2024, 1/1/2023, 1/1/2021, 1/1/2023 in this order, and the adjustable column has corresponding values 100, 200, 300, 400, 500 in this order, and the pointer in cell with the SUMIF formula points to or equals 1/1/2021, then What's Best will read the cell as a formula, not a value, as a formula that's going to be equal to 1, which is going to be a constant, since the pointer is equal to 1/1/2021, and so is the first cell in the fixed column, times 100 as a variable, the first cell in the adjustable column, plus 0, which is going to be a constant, times 200, which is going to be a variable, plus 0, which is going to be a constant, times 300, which is going to be a variable, plus 1, which is going to be a constant, times 400, which is going to be a variable, plus 0, which is going to be a constant, times 500, which is going to be a variable, where the 0 and 1 coefficients are uniquely set by the pointer, and the 100, 200, 300, 400, and 500 are variables, making this a linear function of the form AU plus BV plus CW plus DX plus EY. In other words, each value the pointer takes defines a formula for What's Best, which is equal to F of adjustables. If the pointer is equal to 1/1/2024 instead of 1/1/2021, then the formula read by What's Best is going to be equal to 0 times 100, where again 0 is fixed and 100 is variable, plus 1 times 200, where again 1 is fixed and 200 is variable, plus 0 times 300, where again 0 is fixed and 300 is variable, plus 0 times 400, where again 0 is fixed and 400 is variable, plus 1 times 500, where again 1 is fixed and 500 is variable, and the fixed constants are fixed by the pointer. We're going to build our spreadsheet now. For simplification purposes, we're going to assume annual payment dates instead of semi-annual payment dates. So the first thing we're going to do is build the formulas in our spreadsheet. The annual coupon is equal to the coupon times the principal. We copy that down. We take the sum of the principal column. Notice that in the bond schedule, the dates are out of chronological order. Notice that in line 16, we go back to 1/1/2021. We're going to build our SUMIF functions in columns H and I. This column A is fixed, it will not change. This cell G6 is our pointer. It's pointing to dates in column A. Column B is the principal column, and what's best will vary those. These will become adjustable cells. Copy that down. Same thing for annual interest. SUMIF, column A, the pointer in column G, annual coupons, which are linear functions of the principal. It's a constant times the principal. In this sections, columns L, M, and N, we want to set up the imitation minimum, okay? Put 0 now, down for now. First constraint, minimum is less than or equal to debt service. Go to what's best. Okay. Constraint less than or equal to. Check that the formulas are correct. L6 and 6 is wrong. So we just change the formula. J6. Second constraint. Current minimum is less than prior min. Formula. The L here. L6. For now, we want level or declining debt service. So we set a constraint here in column K. So our debt service has to be less than or equal to the minimum up here. Jason is right. We want a $2 million bond issue. So we're going to set a constraint up here. The principal column has to be adjustables. What's best has to vary them. That's how we're going to solve. Make adjustable. What's best? The imitation minimum has to be an adjustable cell. That's the trick. Adjustable. We want to minimize the first 3 years of debt service. So we take the sum. And this is where we're going to minimize. So we're going to reference this here. You don't have to reference it. You can just set minimum here in J2, but I want to set it in J1 for a reason. Minimize this, set a minimum in what's best. Go to what's best, go to the target and solve. You see we have lower declining debt service. And if we go to the what's best status sheet, we see that it's globally optimal and that it's linear. We do not necessarily have to have it so it's level or declining. We can have, for example, a bump up. So we're going to have a bump up here of 5%. So in our formula, in column K, we're going to multiply one side by 1.005. This is just as an example. You can make the bump up anything you want to. Solve again. See, we have a 5% jump here in year 3. And we can do this with principal or any other linear function of the adjustable cells. I want to show you what we have saved and what our spreadsheet would look like without these two tricks. Without the minimum function, what we'd have to do is we'd have to take the dates and put them across, and we'd have to add in the green section. We have the dates across. Now we have these constraints across here. You can check for yourselves. This is how much we've saved versus these 3 columns here. Of these 4 columns here. So it's 4 columns versus this. This is only for 10 years. If it's for 30 years, it's much more. Without the sum if, this is what we would be saving. Here are these zeros and ones. Here's the date pointer in column A. Here are the dates across. Okay. In row 3, the coupons across in row 3. So we've had to transpose the first schedule from vertical to horizontal here. And here are the printable amounts, the adjustable amounts, here in row 5. So the first thing is the conversion into zeros and ones. And when the date pointer is equal to the date, like 1/1/2021, we will get a 1. Otherwise, we'll get a 0, 0, 0, 0, 0, 0, 0, 0, 0, and then again a 1, and then a 0, 0, because these dates over here are not 1/1/2021. And then these pointers are fixed numbers. We multiply the pointers by the variable cells, by the principal cells here, and then we'd have to sum them across here in column T. You can see the sum here. And that's our spreadsheet for today.